Welcome back to Balmik and Bharti with your mentor Avila Sarkar. So now we'll proceed to the next problem on binomial theory. That exercise I have started already. We have reached number 4. The next will be number 5. So the number 5 problem is it is given if n plus 1 c 3 is equal to 2 to the power n c2 2 to the power n c2. No, it is not 2 to the power, this is nc 2 into nc2, then find n. Okay, then you have to find n. So this n plus 1 c3, how will you explain it? How you expand it is factorial n plus 1 divided by factorial 3 factorial and n plus 1 minus 3, that means equal to n minus 2 factorial, and this side is 2 into factorial n factorial 2 n minus 2 factorial. Now we can assume that, okay, let me take one more ahead. So this will be factorial n, this will be 3 factorial n minus 2 factorial to 2 will be cancelled because factorial 2 and 2 are same. So this is n factorial and n minus 2 factorial. Now if we multiply and keep all this thing on one side, this is n into n minus 2, n into n minus 2 will come. So this will be in one side factorial n, and other things will come in one bracket, n plus 1 this side minus 3 factorial, and everything will become equal to 0. Now, or n minus 2 factorial in factorial, and this is become 3 means 6, 3 into 2 into 1 6, so n minus 5 equal to 0. Now if it is true, so if I say that n is equal to possibility is n is equal to 5, for that it can be 0. For any other reason it cannot be 0. So this and this cannot be 0. So only possibility is that n is equal to 5. For that this equation is true. So your value of for this case is equal to 5. Okay. So moving to next. Number 6. Number 6 is given if NCR minus 1 is equal to 36, NCR is equal to 84, and n plus 1 c, not n plus 1, nc r plus 1 is equal to 126, then the value of r, then the value of r to be calculated. Okay, value of r is how much? The solution, because there are one equation there with r, one equation there, because the unknown are n r, or there are 3 equations. So definitely you can find the value of r. So let us understand NCR minus 1 36, NCR is equal to this, and NCR plus 1 is equal to 126. So Is there any relation in that? No. So okay, fine. If you divide this, so there is chance of elimination is more number of variable in one shot. So what I do, this is 36 by 84. Now if we cancel it, it will give you factorial n divided by factorial r minus 1 into n minus r plus 1 factorial divided by factorial n factorial r divided by factorial n minus r factorial, and there is 36 7 no, this is 18 by 42, further 9 by 4, you can reduce one shot, you can reduce this to 4, 9 by 4, 21. So this is equal to 9 by 21, or further you can reduce 3 by 7. Okay, so 3 by 7. So now if we cancel it, this will cancel. R minus, if we go R, so R will go up, R minus 1 factorial can cancel out, and this will go up, the denominator will remain as n minus R plus 1. Okay, so this is 1. So that equation will become 7 into R, 3 into n, so 3n will be one side, 3 into R and 3 plus 3 if I keep. So other side this will be 7R plus 3R, that is equal to 10R. So this is one equation. You will just remember it when I equalize this, and I will keep this relation there as a first equation. 3n plus 3 is equal to 10R, that is equal to first equation. Now second, if I divide this by this, or the reverse one, r plus 1 divided by NCR, if I divide, I will get 126 by 84. So 4, this will be 6, 6 2 6 1 6 1 6 4, then 7 3 2. Okay, and this will become NCR. So R plus 1 will be there at the bottom, and there at the top n minus R minus 1, I think it will be there, n R plus 1 at the bottom, NCR. So n minus R, sorry, n minus R minus 1, so n minus R, that will go up, and this will be the case. I am just jumping some of the steps. You know how to calculate. What you will do, you will get factorial n, factorial r plus 1 1, another one is n minus r minus 1 factorial, and the below is factorial n, and this is factorial r n minus r factorial. Now if you reverse it, r plus 1 will be there in the denominator and n minus r there, and remaining will be cancelled out. You can check it yourself and you can do it easily. So this will be the case. Now from there, this is 2n minus 2r, and this will be 3r 3. So 2n, and this 3 will come in one side, minus 3 will come that side, and this is 2r plus 3r, it will be 5r, isn't it? 2n minus 2r, that r will go that side with 3, it will be adjusted 5r, and 2n minus 3r, 3 will come, and this is your second equation. Now you can solve it. So 5r, if you can multiply with 2, you will get 10r. So this is 4n minus 6, you can bring it from 2, and then from there n is equal to 9, you will get. Okay, if n is equal to 9, then your r will be 9 to 18, 18 minus 3, 15, 15 by 3, 15 by 5 is equal to 3. So r is equal to 3, n is equal to 9. So what is the value of r? R is needed, so r is value is 3 you are getting. Okay. So the next There is no trick in it. Only thing is that more you able to do faster, you will reach your answer faster. So this is the only the practice. More you practice, your calculation will be faster. You can do it without writing so many steps. So that means your practice. Okay. So you just try at home. More you solve more questions, you will get more faster results. So the next is if expansion. Okay. In the expansion, in the expansion 1 plus x whole to the power 5, the sum of the coefficient of the terms is how much. So you have to find. This is very straightforward question because we have already learned the theory behind that. So any series, if I expand, I will get what? C0 plus C1 x plus C2 x square plus C3 x cube plus C4 x to the power 4 and the end C5 x to the power 5, because that is the end of this series, because highest power is 5. I cannot go beyond x to the power 5. Now the only things it is x. Now if I put x is equal to 1, that will eliminate all x from it, because assuming x is equal to 1. Now that will give you the required demand of this question, that is sum of the coefficients. So only if you can remove x, you will get sum of the all coefficients C0 plus C1 plus dot 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 C5. That is the need, and now result is with you 32. Okay, so the sum of this series where the coefficient, the sum of the coefficient will be 2 to the power 5, that is equal to 32. That already you have learned. The sum of all the coefficients of the series 1 plus x 1 plus x whole to the power n is equal to 2 to the power n. That is following here also. Instead of putting the formula, we have again used the theoretical method to solve this question. Okay. So now the next is 8. So the 8th problem is if 1 plus x whole to the power n. Now the series, c1x plus c2x square plus dot 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 cn x to the power n, that then find the value of one expression is given c0 plus 2c1 plus 3c2 plus dot 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 plus n plus 1 cn. So you have to find the sum of this series. Okay. By using this series, so only help that I can get from this, that if I put x is equal to 1, I will get sum of the coefficients. That is the only help that can be achieved from this expression. Okay, fine. Now if I look at this series, and you can see this is not only the coefficient that is being multiplied with other constants. So the pattern is here 1 and here 1 minus 1. If it is 2, 2 minus 1. If it is 3, 3 minus 1, and like that is going. Let's say I am assuming some common term in between the series is TR, and that can be written as R plus 1 whole to the power CR, because if it is R plus 1, here 1 is reducing, because as same as n plus 1 is equal to Cn. So I am just assuming some common term r which will represent, where we can say that r is 0 to n, any value, because if I put r is equal to 0 here, so this will match the first number. If I put r is equal to 1, it will match it. So this can be a common term, and now this can be written further plus cr. Okay. Now if I slowly put the value of r is equal to, as I said, t0, the intention behind that, I want to make two series of that. One series, by seeing it, you know this is the known series, that I know if I put x is equal to 1, I will get c0 c1, the same series I will get here. Only I have to think in this way. So before putting t0, let me see if I can reduce it to any other way. So if it is r, this is ncr basically, because all the terms is having the maximum power of n. So this is also ncr. So I am not disturbing this. Only if I see this together can brought into some other manner. Okay, so this is factorial r, and this is n minus r factorial, and I will keep this as same. Now seeing this r and factorial can be reduced to r minus 1. This is nothing but what? R into r minus 1 factorial. So r can be cancelled out. So I am writing n factorial divided by r minus 1 factorial into n minus r factorial, and this I will keep same. Now this can be written further as n minus 1 factorial. Now if I see this all together, this is saying something. What is that? N into n minus 1 c r minus 1, isn't it? Because if I break it into, the numerator will be n minus 1, below is r minus 1 factorial, and the next is n minus 1 minus r plus 1. So this I am getting. So this all together I am getting n, I am separating n minus r c r minus 1, and the rest of the term I am keeping ncr. So now without writing all this, if I can write the result as this, by calculating I am getting n minus 1 c r minus 1 plus another term n c r. I can divide it into this two part. So what is the advantage of doing that? Now if I say this is tr, now if I sum of all the tr, where r could be from 0 to n, and the same I can apply here, summing up r is equal to 0 to n here also, and then summing up r is equal to 0 to n. That will follow because I am summing up all the things. N is not varying, so I am keeping n outside the summation. Now see, in this part, you know, this is the coefficient of all, where n is 0, r is 0 to n, and x is equal to 1. I can suppose this is giving the sum of all the coefficients in this series, where x is equal to 1. So putting x is equal to 1, I can say this is nothing but 2 to the power n. X is equal to 1, 2 to the power n. This is giving all the sum of all the coefficients. What about this? Now here one thing you have to understand. If I put r is equal to 0 here, whether any term I am getting here or not, r is equal to 0 means this term is not at all a part of this term. That can be eliminated. Why? I can eliminate because this has been fetched from this term, r into cr. From this term, this has been fetched. Now coming to the initial stage, where r, if I put this r and this r is same, and if I say this is being affected due to the this TR where R is taken as 0 to n, this also should carry R 0 to n, but this has been derived from this part. Whereas if I put R is equal to 0 here, this total term will become 0. So there is no existence of R, because even though if I put R is equal to 0, this is undefined. So any series does not contain undefined. So this is being nullified. This series, number cannot be a part of this summation. So this can be turned into logically into R is equal to 1 to n. This only will satisfy this coefficient. So this can be further reformed into, okay, fine. Now if I say I have to get the summation where R is equal to 1 to n instead of 0 to n, and this satisfies this equation. So if I put R is equal to here, R is equal to this series, instead of n, if I put n minus 1, so what would be the case? This will go till this x will become x minus 1, and this Cn will become Cn minus 1, isn't it? This will follow the same, where R value is, R is taken as, if I put R is equal to 1, so this will become C0, and this is the highest power, so n minus 1 C0. If I put R is equal to 2, this will become C1, and this will go till this series, not the last will not come. So this is nothing but the expansion of this series n minus 1 whole. So if I put x is equal to 1 here, so what I will get? C0, C1, C2 dot 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 Cn. If I put the maximum is n, so this will give Cn minus 1, that is matching, and the sum of this will become 2 to the power, the highest power of the series n minus 1, and this will become 2 to the power n. So this can also be written as 2 into 2 to the power n minus 1 I am writing, just to match the power of 2. Now this, if I take common 2 to the power n minus 1, so the remaining is n plus 2. N here, 2 here. So this will be your result of this series. Okay. So this is one of way of doing. Now another thing that I can think of doing, and the alternate way of solving this, if I say this is Sn, it is C0, 2C1, 3C1. Why I am seeing this? Because this is progressing in an arithmetic manner. Every coefficient is increasing by 1. It is a AP series kind of thing of natural number. Okay, so this is plus dot dot dot. The series ends here, n plus 1 into Cn. Okay. Now again I am writing Sn, but this time I am just reversing the term from n to I am reversing the term starting from end and moving to the beginning. So how will I write? I will write n plus 1 Cn here. The next term will be n into Cn minus 1. Basically this will reduce 1, this will reduce 1, and like that it will go up to the end term will be C0 here. Okay. Now if I want to add this, so how will I get? I will get 2 of Sn, the same thing I am adding, and as you know, the coefficient of the same series from the extreme are equal. So that means if C0, if I say, it is equal to Cn, C0 is equal to Cn, C1 is equal to Cn minus 1. So whatever the terms coming below the other term having same value. So this and this are equal, these are equal, similarly this would be equal to this, and this will be equal to this. So that means how many the same thing I am getting? I can say n plus 1 of same term. Okay, so I can name it as per my convenience, I will keep the thing according to the way the series will be. So I will keep C0 here. Here instead of putting C0, I can name it Cn because C0 and Cn are same. So I will put like that, and every term I will get n plus 2. Here n plus 1 plus 1. So I can write it directly n plus 2, and the coefficient will come as C0. This is my convenience whether I can write C0 or Cn, but I am to keep the way that series is progressing, actual series. So I will write n plus 1, n plus 2, C1, and like that the end term I will write n plus 2, Cn. So this will give you the shape of the series. Now if I take n plus 2 common out of it, what I will remain with? C0, C1 plus dot 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 Cn. So what is that? This is 2 to the power n, because if I put 1 here, I will get 2 to the power n here. It implies if I want to get Sn, which is actual requirement of the sum, but you have to find Sn. So Sn is equal to, I have to bring this 2 down. So this will be n plus 2 whole to the power 2 to the power n minus 1 n, and this 2 will come below. So this will be adjusted in a power 2 to the power n minus 1. So this is the result. So the both way you can see I can get the same result. There are two methods. Okay. So I will end up here. In the next I will start from number 9. Okay. So thank you for now. Good night.